Okay, so, chalk. We've seen that for the more or less truncated square prism that we're measuring, we can represent the sides or the edges as vectors. There are 12 edges, 4 on the bottom, 4 vertical, and 4 at the top are neither vertical nor horizontal, okay? In most cases, some of them are kind of close to horizontal. Okay, so now what we want to do, and what we've done is we've used the dot product to calculate the angles that each vertical face makes with the top, or each vertical edge, the angle each vertical edge makes with the edge on the top that comes out counterclockwise from the end of this vector, okay? We've done that. It's pretty straightforward if you use the dot product correctly. These plus signs are important because it's always going to be tempted to write this as a vector, an ordered triple, okay? Also have to multiply the I component by the I component, the J times the J, and the K times the K, and then add them up. That's all there is to it. One of the simplest calculations you do anywhere in calculus, okay? Then, of course, we have the magnitude that's done by the Pythagorean theorem. And then we have this fact about a dot product when it's defined this way, that V dot W that you calculate like this is equal to the magnitude of V times the magnitude of W, both calculated by the Pythagorean theorem, times the cosine of theta. So from your measurements, you can easily calculate the angles. Now you're calculating the closest angle between this vector and this vector. So they're, these vectors can go anywhere. So the angle between a vector like this and a vector like this is better visualized if you put the vectors so that they have a common initial point, and then the angle is just the closest angle, and it's always between 0 and 90 degrees, inclusive. That's because the cosine of theta, whether the dot product comes out positive or negative, the cosine of theta could be positive or negative, but theta is always going to be positive. Okay? So anyhow, V cross W, okay, now we want to look at V cross W. So, for example, if I want to take this vector and this vector along the top and calculate the cross product, well, here's how you always do the cross product. Cross product is just this, and you use the distributive law like we saw last time. I'm not going to go through that again, but I'm going to write it out for a sample vector, okay? So let's say, example, V equals 10J plus 2K. It's got no I component. And as I've said, you always kind of want to, somewhere in your picture, sketch your X, Y, and Z direction. You really want Z, think of Z right now as being up for reasons that'll be apparent throughout the course. It's just a conventional way to think and a little easier. No reason you can't rotate this thing around to any angle you want to, but this is the simplest way to look at it and the way it's going to be compatible with everything you see in your text and everywhere and in class. So X out this way, Y this way, so it's a right-hand coordinate system. From X to Y is a 90-degree angle counterclockwise. From Y to Z is a 90-degree angle counterclockwise, right? That's what we mean by right-hand coordinate system. Okay, so V, in this case, is going to have a y component and a z component, meaning it will have a j and a k component. W, let's say is this vector, so let's call this one v for the moment. Let's call this w. You have them labeled in different ways, and that's okay. They're all good labelings. So w has going to be a positive k component and negative j component, okay? So that's going to be, let's say it's, now, okay, the w vector here has a negative x component, right? So that's going to be like negative 8i. Let's say it's plus 3k. Okay, Dakota, did you get that mask? Okay, it's easy to forget. So, and incidentally, probably shouldn't be on. One of my buddies from the gym died yesterday, Monday, from COVID, 42 years old. Might have seen him in the paper. He went to Avenue High School, you probably knew him, he was an assistant coach. Good guy. Good guy. He's the second buddy I have from the gym. I don't have that many buddies from the gym, okay, because I intimidate all of them. Yeah, over the years I've had a bunch of them. But out of the 10 best buddies I've had from the gym, that's 2 from COVID, 2 from drug overdoses. Okay? So COVID's something serious. So we take it seriously. Anyhow, so yeah, I'm gonna be on top of this. I was already on top of it. And another thing is, don't do drugs in class. Okay. It's probably illegal. So, okay, we got V and W here. Now let's quickly do V cross W. I'm going to do it in white because it shows up a little better. Blue's kind of pretty. V cross W is 10J plus 2K cross negative 8I plus 3K. Okay? Well, that's going to be 10J. I'm going to write it out with the distributive law, because the distributive law is kind of quicker on this one, because you're going to have a lot of zeros. You're missing an X component here, an I component, and you're missing a J component over here. Now, there's another way to do it. Use determinant, okay? And that's what usually people do, but I want you to see the distributive law first, because that's why the determinant works. Okay, anyhow, you got 10J cross negative 8I plus 10J cross 3K. There are only 4 terms. 2K cross negative 8I plus 2K cross 3K. Okay? This times this, this times this, this times this, this times this. That's a distributive law. Okay, so that's negative 80 J cross I, right-hand rule. J cross I gives you negative K. Now, I wrote those definitions down last time, so you can write them down and get used to them, but also visualize how the right-hand rule does this, okay? So that's going to be negative 80K. And then 10I cross 3K, well, I cross K is negative J, right? And that's going to be minus 30K. Yeah, that's going to work. Okay. Maybe I should have done W cross V, but it's okay. Okay. Then negative 16 times K cross I. Well, K cross I is J. So that's going to be minus 16J. And This is just zero, K cross K is zero, okay? That comes out negative 110K minus 16J. There's a lot of K, not a whole lot of J. Okay? Now the key is, the thing we want to see is, this is perpendicular to both of these vectors. Okay? So that's a big deal. So is the negative of this vector, because this vector kind of goes in this direction. The negative of this vector would be 110K plus 16J. It goes in this direction, kind of out of the top, okay? And whether it goes out of the top or in the opposite direction, just depends on which order you use. I did V cross W because I wasn't thinking ahead. But anyhow, there's a vector perpendicular to these two, and that's a big deal. There's more. One other time, so I say it quickly. Actually, I'm not going to. So, what you want to do is you want to do this calculation for every pair of vectors along the top, every pair that meets. Okay? So I'm going to ask you to do that. Got it? And if you have trouble, send me a sample. You know, calculate one of yours. Tell me what the two vectors are. Show me how you did the cross product. You type it in 2 minutes after you've written it out. Okay? And then I can correct that if necessary, and then you go ahead and do the other thing. Then I'll tell you something to do with the other three. Divide it by the magnitude product, well, divide it by the magnitude of that vector. And then you can tell whether the top is level. And we'll talk about that next time. Okay? Very good, hang on.